Right, integrated problems number 1 from General Chemistry 111. So we're going to talk about the integrated problems, which you'll find on Moodle or in class that looks like this. A whole series of problems dealing with one topic. So this topic is making the perfect cup of coffee. So the first question involved in this integrated problem is to complete the following table about the components of coffee. So we have these list of things here, and we're asked to determine whether it's a pure substance or a mixture. And then if it's a pure substance, we classify it as an element or a compound. If it's a mixture, we classify it as a heterogeneous versus homogeneous mixture. So let's look at this first one. So coffee beans. Coffee beans contain more, they contain a whole bunch of stuff. They contain the starch materials, the caffeine. So this is a mixture. Okay. But if we look at the beans and when we crush it, those beans always look the same. So we're going to call that a homogeneous mixture. Right? So it's a mixture because it contains more than one thing, but when we look at that bean, it's going to always look the same, so we'll call that homogeneous. Now if we look at water, right, if we talk about pure water with nothing else in it, that's H2O, right, which is a compound. So this is a pure substance, but it's more than one element, so we call this a, switching up this is a compound. Right. If we go to sugar then, sugar also is a single thing. There's not a whole bunch of different components of sugar, so this is all, but it's not a single element. So this is a pure substance. But like water, it is a single compound because it contains more than one individual element. The last one that we're going to look, or the second to last one, is the cream. Cream is a mixture of milk, fats, and water. So this is a mixture. But like milk, we can separate out those milk, fats, and the water fairly simply. And if we go down to want to zoom in on it, this is, we see a combination of milk, fat, and water. So this is a heterogeneous mixture, right? Because there's distinct things between the milk, fat, and the water. And the last one here, salt. When we talk about table salt, typically we think of it being sodium chloride. So this is a pure substance. But it's not an element, it is a compound as well. Remember, mixtures are things that contain more than one compound or element. Substances are anything, either a compound or an element. The difference between a substance, pure substance, and a mixture is a pure substance we can't simplify any further without doing some chemical reaction. The mixture, on the other hand, we can typically separate based on physical means. Right? Homogeneous, the same throughout. Heterogeneous, distinct regions. Compounds here are mixtures of more than one element. Okay. So now we've classified these different components of our coffee. Let's continue on the rest of these problems, and let's look at this question here. Some people suggest that to make the perfect cup of coffee, you need a ratio of 1 to 16 coffee beans to water, or 1 gram of coffee beans per 16 milliliters of water. Using this ratio, how many grams of coffee would you need to make a full pot? Here we're calling a full pot 12 cups of coffee, using a normal drip coffee maker. Okay. And we have further classified that 1 cup of coffee is 150 milliliters of coffee. Okay, so how are we going to answer this question? Well, we know we want to start with, we want to know how much coffee we need, grams of coffee we need to make a full pot of coffee. So we're going to go from a pot, right, that's the amount we want, to figure out how many grams we have there. And then we're going to use these other ratios to answer that question. We know that we want one pot of coffee. And in that pot of coffee, we're going to use this ratio. The information we have about the coffee beans is in terms of water. 1 grams of beans per milliliter of water. So we're going to have to go from this pot of coffee to milliliters. And we know that 1 pot of coffee is equal to 12 cups of coffee. So that gets rid of the pot. So now we're talking about how many volume in cups. And from here, we know that for every 1 cup of coffee, we end up with 150 milliliters of coffee. Right? And then from above, we know that we want for 1 gram of coffee for every 16 milliliters of water. So we want 1 gram of coffee for every 16 milliliters of coffee that we make. So if we see that now, our units are left with grams of coffee. So we now, using this dimensional analysis, we know how much coffee we need to make a single pot. And if we do that math, we see that we get, straight out of the calculator, 112.5 grams of coffee. But the last thing we need to do is think about significant figures. Right? If we look here, the number of significant figures, since we're doing multiplication and division, the significant figures in our answer is going to be related to the fewest number of significant figures here. So we see we get the fewest number. We have 1, 2, 1, 3, or excuse me, 2, 1, 1, and 2. So the fewest number of significance figures we have in our problem is 1. So we should have an answer that has 1 significant figure. So we're going to round this number to 1 significant figure, which is 100 grams of coffee. Right? First digit significant, these 2 zeros insignificant because they're to the left of the decimal, no decimal showing. So to make our perfect cup of coffee, or pot of coffee, excuse me, we're going to need 100 grams of coffee beans. All right, next question. Using the value of how many cups of coffee you can make, using this value, 100 grams of coffee, how many pots of coffee can you make from a 1-pound bag of Starbucks French roast coffee beans? All right, so we know we have 100 grams of coffee for the perfect pot. We then have to convert this. So from the previous problem, we know that we had 100 grams of coffee is equal to 1 pot of coffee. Is needed to make 1 pot of coffee. So we want to know how many pots we're going to need. We're going to have to start with this mass. So we're going to start with the 1 pound of coffee, the Starbucks coffee, and we're going to need to convert that to grams. So we have to convert this pounds to grams. So off of our periodic table exam sheet, we see that for every 1 kilogram of mass, that's equal to 2.205 pounds. So this is the equation we got off of our exam, or our constant sheet. So now we're left with kilograms of coffee. Up here we have grams of coffee, so we have to do that conversion. So we need to get to grams. So we want grams on top, kilograms on bottom. Prefix, so the prefix for a kilo is 1 times 10 to the third. So now we're left with grams of coffee. We don't want grams of coffee, we want pots of coffee. So then we're going to use this value up here. For every 100 grams of coffee, we get 1 pot of coffee. Again, do that math. Multiply the things on top, divide the things on the bottom. We get a mass of a number of 4.53 pots. But again, we have to worry about significant figures. This number that we started with only had 1 significant figure, so our answer should only have 1 significant figure, which means we're going to round this. To make sure we have a perfect cup, we're going to round this one down in this case to the even. So we're going to make 4 pots of coffee. So with this perfect cup of coffee, which is 100 grams of coffee per 1 pot, with 1 pound, we're going to be able to make 4 pots of coffee. Okay. The next question is, how many cups of coffee will this give you? Right? We said from the last problem that we're making 4 pots. Right? And if you remember from this very first problem, that a full pot is 12 cups. So we also have from a previous that 1 pot of coffee is equal to 12 cups. Right? So if we're making 4 pots of coffee, and 1 pot is 12 cups, that gives us a value of 48 cups. Again, we're counting these cups, so we can leave this as 2 significant figures, even though it should technically only have 1. This is something we can do by counting, so we're going to say that that is an exact number. So our 1 pound of coffee that we had, making that perfect cup of coffee of a 16-to-1 ratio, we're going to end up making 41 cups. So for 1 pound of coffee, this says that we're going to make 48 cups of coffee. Next, so according to some, the proper temperature of water to use to make this perfect cup of coffee is 93 degrees Celsius. We don't want fully boiling water, 100 degrees Celsius. We want slightly lower than that. So let's convert this temperature of 93 degrees Celsius to both Fahrenheit and Kelvin. So if we remember that Kelvin is an absolute temperature scale, in order to get that, we're going to take the degrees of Celsius plus 273.15 Kelvin. Right? So this is the amount of Celsius we have to add to get to Kelvin. Also, if you remember that our degrees Fahrenheit is equal to 9/5 degrees Celsius plus 32. Again, so these are 2 conversions that you probably should be familiar with, although I believe they're both given on the equation sheet, but you still should be familiar with these 2. So if we're looking at here for 93 degrees Celsius, to free that in Kelvin, we take that 93 plus 273.15, we end up getting 366.15 K. But remember, we have to worry about significant figures. We are now adding these 2 numbers together. The rules for significant digits for addition is we go to the one with the fewest number of decimal places. This one has 0 decimal places. This one has 2 decimal places. So we're going to go to 0. So we're going to have to round this off so we get 366K. We can do that same thing here to figure out Fahrenheit. We're going to take 9/5 times the temperature in Celsius plus the 32. Do that math. We end up with 199.4 degrees Fahrenheit. Again, this has 2 significant figures, so our answer here should have 2 significant figures. The best way to do that, we're going to have to round it to 200, but to show the 2 significant figures, we're going to put that in scientific notation, 2.0 times 10 to the second degrees Fahrenheit. Again, now the 2 significant figures comes from the fact that we're here. So also remember that this Kelvin is an absolute scale, so there's no degree symbol here, while the Fahrenheit is a relative scale, so it's going to have a degree symbol. All right, moving on. So if we look here, others suggest that to cut the bitterness of a cup of coffee, you should add a pinch of salt to the grounds for each cup of coffee. So the salt is going to be there to cut the bitterness of a coffee. How many grams of salt should you add to making a pot of coffee? And you may not know that a pinch, that measurement when we talk about a pinch, actually has some actual value, and by definition it's 0.25 grams. Right. So again, if we think about how we're going to solve this problem, we know we're going to make a pot of coffee, so we're going to have to go from pots of coffee to mass of salt, because that's what we're trying to determine. Right? So we want to start with this 1 pot of coffee that we want to make. And we know from before, again, that for every 1 pot of coffee, there's 12 cups of coffee. Right? We have to go to the cups because this is the amount of salt we have to add for every single cup. And that ratio is 1 pinch. For every 1 cup of coffee, we need 1 pinch of salt. Right? But we don't want it in terms of pinches, we want it in terms of mass or in grams, so we're going to use this ratio. 1 pinch is 0.25 grams. Right? So, do the math, multiply on top, divide on the bottom, we end up with a total of 3 grams of salt. In this case, when we look for significant figures, this actually gives us a whole number, so our answer is still going to round to 1 significant figure, or 3 grams of salt. Right? So in that whole pot of coffee, that 100 grams, we're going to add 3 grams of salt to it. So if you don't like your coffee black, like some people, you might add cream to it. So some people like cream in their coffee. I'm not sure why. That's a statement that I added. If a person adds 2 packets of creamer, each of about 0.38 ounces, to their cup of coffee, how many milliliters of creamer do they add? Right? And we need to know that 1 fluid ounce is equal to 29.57 milliliters. So now we want to start with information about the packets of coffee, or cream, excuse me, to figure out how many milliliters of cream that is. And we're going to have to go from packets to ounces, ounces to milliliters. So, if we have 2 packets of cream added to our coffee, and 1 packet has 0.38 ounces, and 1 fluid ounce is equal to 29.53 or 57, excuse me, milliliters. Now we see that the units end up with milliliters, which is what we want. Do the math. 2 times 0.38 times 29.57 equals 22.47 milliliters. Again, we're going to want to round to the correct number of significant figures. We have packets here, so that's 1 significant figure, so this is going to equal 20 milliliters of creamer added. Continuing on, we're going to talk about people also adding not only cream but sugar to their coffee. If a person adds 2 teaspoons of sugar to their coffee, how many grams of sugar have they added? Bearing in mind that a teaspoon is a unit of volume typically, which is 5 milliliters. Right? So we're measuring a volume, we want to go to a mass. Right? In order to go from volume to mass, we need to go through a density. Right? So if we want to go from a volume to a mass, we have to use the density. So in this case, we're going to start with this 2 teaspoons of sugar. Right? And each 1 teaspoon is 500 milliliters in volume. Right? And for every 1 milliliter of sugar we have, we get 1.27 grams of sugar. Right? So our volumes are going to cancel. We're going to be left with grams of sugar. 2 times 5 times 1.27 divided by 1 is equal to 12.7 grams of sugar per cup. Again, going to significant figures, this is 1, excuse me. So we're going to be left with 10 grams of sugar. So let's just take a minute and think about this. So now we're having, in our perfect cup of coffee, we have 100 grams of sugar. So in 1 pot of coffee, or 1 cup of, so for coffee, we found that we need 100 grams of coffee for 12 cups, or 1 pot. Right? In that, to cut the bitterness, for every 1 pot of coffee, we found that we had to add 3 grams of salt, right, to cut the bitterness. And then for every 1 cup of coffee, we found that we added 20 milliliters of cream. And for that same cup, we found that we just added 10 grams of sugar. So let's take a minute in this next problem. Using all of this information, let's think about what happens if we go to the store and buy some amounts. Right? If you were to the store and bought a pound of coffee, a pound of sugar, a pound of cream, and a pound of salt, which you plan to only use to make coffee, which of these things would you run out first? Right? So we have to figure out, convert all of these values into a single unit. And the easiest, so we're going to have to convert all of these from pounds to pots. So we're going to start with this 1 pound of coffee, the 1 pound of cream, the 1 pound of salt, and the 1 pound of sugar. And we're going to take all of these measurements and somehow get them into pots of coffee. The one that gives us the fewest number of pots is the one that we're going to run out of first. Right? Since they're all in masses, most of them we're going to have to convert from some English unit of mass to some metric unit of mass. So let's start with the coffee. Again, remember in the first problem that for every 1 kilogram we ended up with 2.205 pounds. Right? That same conversion we used in the very first problem. Right? Also remember that we said that 100 grams of coffee is needed to make 1 pot. So that means we have to convert this kilogram into grams. So 1 kilogram is 1 times 10 to the third grams. Again, prefix, prefix, base unit. And from before, 1 pot of coffee is required, is provided when we make 100 grams of coffee. So if we do this math, we see that we end up with 4.5 pots of coffee. So 1 pound will give us 4.5 pots. We saw that number before. We rounded it down to 4, but we're going to leave it unrounded this case. Right? The cream, however, if you remember when we did the cream problem, we had it in terms of volume. So we're going to have to do something a little bit different. Right? For 1 pound, we had a unit of ounces, if you remember that. Right? 2 packets of creamer, each creamer has a 0.38 ounce. So if you remember that 1 pound is 16 ounces, right? So we're going to convert this pounds to essentially packets, packets then to pots. For every, we got 30.38 ounces per 1 packet of creamer, and we took, I said earlier, 2 packets per 1 cup, and a full pot of coffee, remember, is 12 cups for 1 pot. So again, we went, instead of going through grams, we had it in terms of this other unit, packet. So we went from pounds to ounces to packets to cups to pots. We do that, we see that we end up with 1.75 pots. Now, the information we had about the salt was in terms of mass per pot. We had 3 grams per every pot of coffee. So we're going to do something similar to this one that we did with the coffee. We're going to convert to grams. And then from kilograms to grams, just like before. Now, we said that for every 3 grams of salt, we make 1 pot of coffee. For this, we're going to find that we have enough salt in a pound of salt to make 151 pots. And we're going to do, again, the sugar. For our sugar, we said that for every cup of coffee, we needed 10 grams of sugar. So we're going to go to grams again, 2.205 pounds for 1 kilogram. 1 times 10 to the third grams per 1 kilogram. and then 10 grams of sugar for 1 cup, and 12 cups for 1 pot. And we figure out that we make 3.77 pots of coffee that way. Right? So now we have this same mass here. Now we can make a comparison because we know how many pots of coffee we'll be able to get out of that individual item. Right? So we see that we have 4 less than 2, 151, and 3. So that must mean that this is going to give us the fewest number of pots of coffee. So sugar, or excuse me, cream, runs out first. We'll have to go and buy more cream before we can continue enjoying our coffee. And the last problem here, how many cups will you have made based on those 1 pound of everything? Right? From this last question, we saw that the cream gave us about 2 pots. Right? So for 2 pots of coffee, we end up with 1 pot gives us 12 cups. That gives us 24 cups of coffee. So we've answered a whole bunch of questions now related to this single idea of this cup of coffee, and carried information from one problem on through the next. So that's the end of our integrated problems number 1.